Our next session is with our wonderful new sponsor, Basis Charter Schools. We're so excited to have them join us today, and they are going to be sharing with us all about coding, programming, and microcontrollers. So welcome. Thank you for joining us.
Good morning, everybody. I'm happy to be here. I hope you all do well. I'm Mr. Matthias Huth. I'm from Basis Charter Schools, and I will talk a little bit about how microcontrollers, small computers, are used almost everywhere in our daily life to control daily life tasks. I will go ahead and share a PowerPoint that I have prepared. Just real quick, can everybody hear me?
Yes, we can.
Great. All right. I am a third grade math and science teacher with Basis. I work downtown at our Central Phoenix campus. It is located at Indianola Avenue in Phoenix, close to Indian School and Central Avenue. What will I talk about today? I want to talk about what microcontrollers are. I will go a little bit over how they are used in daily life applications. I will shortly talk about embedded systems. I will talk also about computer basics and how it all started, how they are used, how microcontrollers used in those systems. I want to talk about how microcontrollers are just like small computers. I will go over how an embedded system works, and I will have some references. At the end of my presentation, I will show you an application, a real-life application that I used to build during a club that we do in school. So we have a club, coding and electronics club, an afternoon activity. And during this club, we are going to build circuits using microcontrollers to have fun with it. What are microcontrollers? Microcontrollers are very small units. As you can see in this picture, that's about a real size image. This is how small computers have become. Microcontrollers are used to control daily life tasks. They are just like a PC, and just like a personal computer, they contain different components, such as a processor, which is the brain of the computer, or here in our case, a microprocessor. Microcontrollers are very small and can be used in many of daily life applications. You find them in cars, your cell phones, or game consoles, televisions. Even in your microwave, you can find a microcontroller. What are some daily life applications and embedded systems? We find microcontrollers and embedded systems, small computers, in the medical field. They're to monitor and maintain patients' health, to take temperature, or to monitor your heart rate. People with diabetes, they have an insulin pump. The insulin pump is also controlled by a small computer, a microcontroller. We find embedded systems and microcontrollers in communications, cell phones, and cell towers, for example. Rail-based signals are controlled by small systems. We find microcontrollers in aircrafts, for navigation systems, for example, and of course, another application is the aerospace, NASA, for example. You see a picture down here. Here's a small cube satellite. Cube satellites are used to transfer information on Earth surface information, weather, for example. Here we have a medical application, patients' health monitoring systems, where microcontrollers are used, and also, for example, for railways or even traffic lights. Traffic lights are usually controlled by microcontrollers. Let's talk a little bit about the basics of computers and how it all started. Our everyday computers use what is called a binary system. A binary system is a system that uses combinations of zeros and ones to code a certain value. Letters, for example, writing, numbers, or whole tasks, commands. For example, the binary code for the number 1 is 0001. To show the number 1 as a physical or screen number 1, we need to code that number, and the code contains of zeros and ones. And in this example, it's 3 zeros and 1. Ones and zeros are signals. Signals can be used to close or open electrical circuits. 0 indicates that the circuit is open. No electric current can flow. 1 signals that the circuit is closed. Electric current can flow. And those zeros and ones and those signals are not only 2 signals, open or closed. It's millions and more of those signals that are going to be processed in a microprocessor, for example. Here's an example for an open circuit. If the circuit is open, no electric current flows. If the circuit is closed, this light bulb turns on. How are microcontrollers used to control daily life tasks? So the control of daily life applications is much more complex than showing numbers on a screen, as you may imagine. Many of 0 and 1 combinations are needed to control complex applications. A microprocessor or microcontroller can process those informations, many of them, in a very short amount of time. Microcontrollers are used in many different ways. For example, to control traffic lights, microwaves, security systems. They are used in satellites or, as I already mentioned, in medical applications. Here are some examples. On the right side is an example for a microprocessor that not only contains of a processor, which is that squared unit here, but many other components such as resistors, transistors, etc. Microcontrollers are small computers. In order for a computer to show, for example, letters or writing, numbers, or do certain tasks, it needs to process the combinations of zeros and ones. It opens and closes the circuit in the processor millions of times. And the computer knows what it needs to show or what it needs to do using the information, opening and closing the circuit. The combination of open and closed circuits make a certain task or show a certain letter or picture or other things. All the processing is done by a microprocessor or a processor, just like a processor in a computer. Here's a picture of a processor. It's a small unit. Electric current flows through this microprocessor millions of times in seconds. This is why our computers need fans to cool those microprocessors down when they do their work. Small computers that use microprocessors are called microsystems. Small systems that don't even need screens, or we don't even see them. For example, a traffic light has all the small embedded systems inside the pole. So you don't even see it, and a bigger computer is not even necessary to control, for example, a traffic light. And we want to go back to that example when I show you the application here that I have prepared. How does an embedded system work? Any microcontroller needs information. Just like we need information, if somebody tells us you need to do this or that, a computer needs to know what it needs to do, and it only does what we tell it to do. We call those information input. Remember, those are the combinations of 0 and 1s. The computer needs to know what it's supposed to do or show, and this we call output. Everything the computer or our microsystem does is the output. We tell it what to do, and the computer does it. Modern programmers use languages, just like we use English to communicate. Programmers use languages to communicate with computers, or here our microcontrollers, which is a small computer. Programmers write code. Those are many of informations, commands, in order to control, let's say, a traffic light. Let me stay with this example. To tell a microcontroller or a microcomputer that the green light has to stay on for a while, then to switch to yellow and to red, and how long the lights need to stay on, that needs to be communicated. Instead of typing a very long combination of 0 and 1s, programmers use short languages to talk to the computers. Many different computer languages exist. For example, one of the more famous computer languages, C++. You may have heard about Java, Python, Blocky, etc. A program is used to write the commands. We call the program we use to write the command software. The transfer happens to the hardware. Hardware is everything like lights, a monitor that shows something that is actually physical existing. Today, we want to use an open source program. It's called Arduino. And we use C++ as a language to communicate. Here I have a screenshot, and I will show this later to you, with some commands that we will use to build a small traffic light using a microcontroller, using components, most importantly, our red, yellow, and green LED lights, some wires, and some resistors. What do we need to build? We need our microcontroller. I have chosen to use a Pro microcontroller. We need a breadboard. A breadboard is a small board that allows us to connect wires, LEDs, and our components to the microcontroller. We need our cables, we need the LEDs, and today we need only 3 resistors. Our software is Arduino 1.8.13, and we need a USB connection and a cable to power our microcontroller. The USB cable is connected to the computer. So let's have a look. Here, on the right side, I have prepared my breadboard already. As you can see, here I use a microcontroller, Pro Micro. In the heart of the controller is the processor that processes my information. that I give or send to the microcontroller using Arduino. This is my platform for the programming. I already have prepared my code, but I want to explain a little bit what I did here. We want to build a traffic light controller. So we want to actually tell our LEDs without pressing any buttons or needing to stand there to switch lights and change lights, that our microcontroller needs to turn on and off lights in certain intervals. Let me talk a little bit about my breadboard here. In the bottom is the breadboard. The breadboard has inputs. I connected my microcontroller in those inputs. The microcontroller itself has output pins. They are labeled. So if you have a closer look, let me enlarge this a little bit. Here on the left side, where the cursor points at, we have pin 9, pin 8, and pin 7. There are many more pins that can be used as output pins to control here our LEDs. They also can be used as input pins. That means, for example, if we have a thermometer and we want to connect a temperature sensor, which is possible, we could do this also using the same microcontroller. We could connect a temperature sensor, and we could connect a small screen and could write code to make this microcontroller show the temperature on the screen. But today we want to go a little bit simpler. So we want to just look at a daily life application like a traffic light and want to build a small traffic light here. We use the connections 9, 8, and 7, 7, 8, and 9. From those output connections, pins, we go and connect the cable. My pin 7 goes all the way down to the green light. In between the cable and the LED is a resistor. The voltage of the microcontroller is 5 volts, but our LED only needs 3 volts. So we bring that down using a resistor. Yeah, it slows the current down. My pin 8 is connected to the yellow LED, and my pin 9 is connected to the red LED. To close the circuit, we need to go from the pin to the resistor to the LED, and on the other side to the ground. And if you look closely here, this black cable is connected to the ground pin. It goes in the breadboard, and here is the connection made to all 3 LEDs. By the way, those circuits are all parallel. So we have 3 parallel circuits here for our 3 LED lights. Now let's have a look at the software. Software is used to tell this little board here what it needs to do with the LEDs. The first thing I did was to tell the board that my pins number 7, 8, and 9 are connected to a certain color. Pin 7 is connected to red. That's what I tell it here. Pin 8 connected to yellow, and pin 9 connected to green. Now I want to also tell, or I already told, using those commands, the board, the microcontroller board, that my red, yellow, and green pin, 7, 8, and 9, are output pins. So everything I tell the board to do will be transferred over to the LEDs. So it is something that the LEDs will need to do. Now, what do they need to do here? We switch over. In this state, they don't do anything. In this state, they are just turned off. In the next command, it's called digital write. What do we want the LEDs to do? Here, our green LED says low. Low means it's off. It's just like 0. It tells it, okay, low, there's no connection, there's no current flowing through the circuit. We call it low. Low means off. Yellow is off, red is off. All 3 LEDs off, as you can see. Now, that's a very short code that I wrote here. In the next step, we don't want to have all LEDs off. We want to actually make those LEDs do something. And this is what I told the microcontroller here. We still have our output pins, red, yellow, and green LED. Now I tell the microcontroller that it needs to change lights. My delay time is 10 seconds or 10,000 milliseconds. We say we want to turn on green light and we want to turn off red and yellow. Only green light should be on. So we tell red, low is off. We tell green to be high, which means on, and how long it should stay on. It should stay on for 15 seconds or 15,000 milliseconds. In the next step, we turn green off. Yellow turns on for 3 seconds. We tell our system to turn off green, low means off, to turn on yellow, and I told the system to turn on yellow for 6 seconds or 6,000 milliseconds. In the last step, turn off yellow, yellow turns off, the red light turns on for 8 seconds. We write yellow, low, off, digital write for red is high, turn on for 8 seconds, delay 8,000 milliseconds. And in the last step, red turns off and green turns on, just like as if we would wait at the intersection. Yellow turns off and the whole cycle starts all over again. Well, how do I get this information to my physical microcontroller? Well, here is a command that says upload. And since my board is connected to the software, to the computer via USB cable, I can just press the upload button. And let's see if everything we told the controller to do and our LEDs, if this actually goes through and we have a perfect working traffic light. Let's see. So the system is uploading and here we go. Our green light turns on for 10 seconds. Then our yellow light turns on, just like at the traffic light on the intersection, and red turns on. Red stays on for 10 seconds. And green turns on again. And the whole cycle starts all over again. Well, if we think we need more time to let, during rush hour maybe, to let more cars go through, then we can go back in our software and we can just change the parameters, the delay for green, for example, instead of 15 seconds, we keep green on for 20 seconds, 25, or even longer. If we need a longer red phase, we need to change our delay for the red light from 8 seconds, maybe 12, 15, however long we need it. Well, in case there's a power outage, for example, our traffic lights all have backup power, batteries. So you notice sometimes when traffic lights are off and not working, that the traffic lights just blink yellow. And we can actually program our traffic light here to do the same, to blink yellow when the power is out, or another situation is going to happen where we don't have a working traffic light. What did I do? I work with the same, if you want to have a look, I work with the same commands. I still have 7, 8, and 9 as my output pins. But here I tell green to stay off. I tell yellow to turn on for 800 milliseconds. Then I tell yellow to turn off for 8 milliseconds. And I tell red to stay off. Let's see how this looks like. It's an easy, short code, short command chain that I wrote here to control just those 3 LEDs. Let's see how this looks like if the traffic light is off. So I uploaded the code, and as you can see, our yellow light blinks. And as you know, this is what it sometimes looks like at an intersection. If you're interested, if you're school students, you're interested, our school offers an afternoon club where we exactly do this and other fun projects, not only traffic lights and LEDs. We are going to build small vehicles that don't run into walls because they use sensors to make them turn around, and other fun stuff. Then get in contact with BasisHead. Our campus is downtown Phoenix, right on Central Avenue and Indian School Road. That should be it from me to you. You can now ask some questions. We are open for in the chat, and we are happy to answer all your questions. Thank you for being attentive.
Thank you so much, Matthias. This was wonderful. I can tell you that probably those third graders that you teach are way smarter than I am. There was a question on the traffic lights of, do the lights, do they change them based on how many cars there are, and how does it know it? So are there sensors that can change the program based on the traffic?
Yes, definitely. Yes. We just built an easy system that works always within the given parameters. Real traffic lights have sensors, photo sensors that actually count the amount of cars that go through the intersection and adjust then the intervals for the lights. Yes.
Great. And there was also a question about if somebody wanted to build their own micro computer, where can they buy parts for that?
All online platforms, all online stores sell those parts and components, mainly online stores. Yes.
Wonderful. Well, thank you so much. This was fantastic. If you'll stop sharing your screen,
great.
I'll close us out. And again, thank you for your time. And also thank you to Basis for your wonderful sponsorship, for supporting all of our activities that we've been doing with Connect2STEM this year. Thank you.
Yeah, thank you.
All righty. So I am going to close us out quickly. I'll try sharing my screen again and make sure that my program still works. We've got a thank you from our Be Kind crew. But before I do that, I do want to say congratulations to our t-shirt winners for today. We have Rachel C, Yan M, Devanish R, Lewis H, and Arjun M. We will be in touch with you, and anybody who won t-shirts in the past few weeks, we will be sending them all out next week. So look for those to come in the mail. So here is a thank you from our Be Kind crew.
Learning about STEM is fun. Be sure to check back for more Connect2STEM TV. There's lots more to do. Don't forget you need to register here. Special thanks to our sponsors, Banner Health, APS, for their great support. And be sure to follow Connect2STEM on Facebook.
And just a reminder that we will be sending out all of the links for all of the sessions. You can see them all on our YouTube channel. All of the videos from all the past sessions will be on that link. We'll make sure and get that to you. Thank you for joining us for the past 4 weeks. We look forward to seeing you soon at an in-person event. We can't wait to share more with you about our wonderful STEM activities here in the Arizona area, both in Phoenix and Tucson and around the state. And we really appreciate you joining us. Take care, and we'll see you soon. And don't forget, bear down and mask up.